All right, guys, this is it. This is the last section in our graphical models chapter. It's on exponential models. When we're done this, well, on Wednesday, I'll be posting the chapter assessment. You'll have 3 days to do that, and then we'll be on to chapter 6. So exponential models, away we go. I'm going to try and keep this quick because bandwidth is at a premium at my house. So consider this. You're offered two different jobs. $10 an hour for both of them. But job one, it's $10 an hour, plus you get a raise of $1.20 each year. Job two, $10 per hour, plus you get a 10% raise each year. What job do you think offers the best rate of pay? Well, at first glance, you might, if you just do some quick math in your head, you might think, okay, $10 an hour plus 120, after a year, you're $11.20 an hour. It's going up by $1.20 a year. Whereas 10% seems like a small amount, but let's do a little bit of math here. So job one, you get an hour, $1.20 raise each year. So years of work, 0, they're both $10 an hour. So after 1 year, I've got $10 plus 120. I've just got my calculator rolling here if I stutter a little bit. So like we said, $11.20. And I'm just going to keep adding $1.20. Sorry, I'm just struggling to add $1.20 on my calculator. And 1240 plus 1.20, 1360, 1480, $16, and 1720. Not bad. 6 years in, you're making $720. Job two, it's not a whole lot more complicated. To give yourself a 10% raise, you multiply by 1.10. The 0.10 is 10% in decimal. 10% is equal to 0.10 in 10. So I go 10 times 1.10. Well, that gives me 11 after the first. So already it's not looking that good, is it? So again, I go times 1.10. On my calculator, I'm doing that, 1.10, and now I'm at 1210. Still lower, times 1.10. 1331, oh, it's catching up. Each time I'm just typing in my calculator times 1.10. 1.10 times 1.10, 1460, 1610. Now for the first time we see job two is ahead. And then lastly I got 1772 if I'm to round it off. Each time all I've done to get the next one is multiplied the previous value by 1.1. So as you can see, the first job starts out better. But if you're going to work at that job for any more than, 5 years, getting that percentage raise is better. So job one is something we've already covered. It's a linear relationship because every year you get the same amount added to your wage. Job two is an exponential relationship since every year the hourly wage is multiplied by the same amount. So if I want to know my hourly rate, let's just call it A for amount. In this case, it would be $10 plus $1.20 times N. We'll call N the number of years that you've worked. Okay, so at 0 years worked, $10. 1 year worked, $11.20, and so on and so forth. Whereas in this guy here, every time I took $10, my initial rate, times 1.10, And that 1.10 is multiplied by 10 to the power of the number of years that you've worked. Now, just to make sure we did that right, if I look back and see what were those last two values, 1720 at 6 years experience, and 1772 at 6 years experience. So let's go ahead and I'm just going to get back to that slide and see if I got those equations right. So in equation 1, 10 plus 120 times 6 equals 10 plus $1.20 times 6 equals 1720. So I got the first equation right. We're just double checking here. Second one, 10 times bracket 1.1 to the power of 6. And it gives me back that 17. Well, I'll write in what I put. So $10, 1.10 to the power of 6. All in one step gives me 1772. I rounded that last digit. It was actually 17.715661. Now, well, we're going to see it on the next slide, but the n is your variable. No, there's one that's the hallmark of an exponential growth, is that the variable is the exponent. In here, you've got your rate of increase, and then over here, you've got your base amount or your starting amount, all right, in that equation. So ways to recognize an exponential relationship: exponent is always in the variable. The first and second differences, if you liked that method, are never the same, but the ratios are the same. And the curves only go in one direction. So, and by one direction, I mean, like, you know how the quadratics, they can go like this or they can go like this. Not these guys. Either it's an exponential increase or an exponential decrease. An exponential increase or an exponential decrease. So let's see. Take it just a little bit further to 20 years. Let's say you like that job and you're sticking with it for 20 years. Let's see what you're going to be making with that first job. What was it? 120 times your year's experience. I'm just punching that into my calculator now. 10 plus 120 times 20. $34 an hour. That's pretty good. That's fantastic living, isn't it? Now let's take a look at the second one. If you get a 10% raise each year. So that's that initial $10, 1.10, the 0.10 representing your 10% raise each year, to the power of 20 years. 10 times 1.10 to the power of 20. I got $67.27 per hour. So as you can see, over the long term, you get a much better wage at job 2. As a matter of fact, if I go back to this slide here, and I know the numbers aren't exactly the same, but if we just forget about the negatives, and there's your exponential growth pattern. So the linear growth, it stays above it to a point. But as you can see, once you hit that crossing point, the exponential growth gets higher and higher and higher and higher, whereas the linear, it is growing, but that linear growth is much less. I'm just drawing it again, just a little bit neater, a little bit nicer, right? So for the first few years, it looked like that linear growth was going to be better, but the exponential growth, once it crosses it, that's what lands you at your 34 or whatever we got here, and the 67 over here. So that's the difference between linear and exponential growth. Exponential functions are the theme of this lesson. I don't think there's anything else you really need to know from me in order to do these required questions 2 to 7. Your assessment on Wednesday will just be based on the sections that we covered, which we skipped one. So what is this, 5.5? So that means there's 4 sections There's 5.1, 5.3, 4, and 5. So that's 4 sections that you're going to have to be responsible for. I'm trying to come up with some good multiple choice questions I can throw in there, like, which of the following is exponential, which of the following is linear, which of the following is quadratic, that sort of deal. Just to try and keep down the written output that I have to read, I guess. Anyway, I said bandwidth was at a premium, so I better get out of this. Let's keep our annotations, and we'll get into here. So good luck, guys. Email me if you have any questions about that or about the chapter assessment we're going to do later in the week. Okay, that's it.